In this demonstration, we'll be running samples that contain amplified fragments which are a few hundred base pairs long. For this reason, a 6% gel would be ideal. For a full plate, we would require 125 ml of gel solution. Volumes for other plate sizes can be found in the Kirkhouse Trust hPAGE protocol. To prepare 125 ml of 6% gel solution, I would need 18.8 ml of acrylamide and 3.7 ml of water, which has already been measured out in this 50 ml centrifuge tube. So I pour this in the glass beaker. I would also need 2.5 ml of 50 times TAE made up to 50 ml with water in this 50 ml centrifuge tube. I'll then add this to the acrylamide solution and water. Then I'll carefully swirl to homogenize the mixture without aerating it, because the introduction of oxygen inhibits polymerization. This solution can then be kept at 4 degrees until when required. Before dissolving the APS 10 tablets, it is worth noting that these tablets should be stored in the refrigerator when not in use. Also, being a hygroscopic substance, the container should be pre-warmed to room temperature before opening it. And lastly, the tablets being fragile, it is also worth noting that appropriate care should be taken when handling. For instance, to obtain the required amount of tablets, it is advisable to place the required number of tablets on the cap of the container rather than using a pair of forceps to pick them individually, as this can crush them. So to prepare my APS solution, I would need 2 APS 10 tablets. So I'll place the required number in the cap rather than using a pair of forceps. So as earlier mentioned, this component helps to catalyze the polymerization reaction. So I add these tablets in 50 ml of water. So to quicken the dissolving process, you can either roll the tube on a hard surface or invert the tube forwards and backwards until the tablets is completely dissolved. Now that our APS 10 tablets has completely dissolved, we then add this to the rest of the gel mixture, and once this has been added, polymerization has commenced. So we swirl quickly but carefully so as not to aerate the mixture, just to homogenize all the components. And once this has been mixed, you pour it on the gel mold, starting along the row of teeth and working your way through the mold. So you save up about 1 ml of the solution in the glass beaker, which would then be pipetted in the microcentrifuge tube. This is just to monitor the time it takes for the gel to polymerize. And then, just to ensure that there are no air bubbles across the row of teeth, you can either use the edge of your glass plate and just draw the solution across the gel mold. Alternatively, you can also use the tip of a spatula and just draw this about 2 to 3 times across the row. Polymerization has started, so we need to be quick. Apply the silanized glass plate, starting by placing the edge of the glass plate at the topmost part of the gel mold and gradually lowering this while the solution moves across until the other side of the mold. You need to be careful so as not to form air bubbles. You may have some excess gel seeping to the surface of the glass, but this can be wiped using some paper towel. And then I pipette 1 ml of the gel solution that we've saved up into the microfiche tube. So this will help us to monitor how long it takes for the gel to polymerize. Usually it takes about 10 to 15 minutes for the gel to polymerize, and how you can tell is that gradually the gel color begins to turn opaque, and that way you can know that the gel has started polymerizing. So we would leave the cast gel for about 1 hour to ensure that polymerization has taken place and has been completed. Fill the gel tank with 1 times TAE running buffer. Make sure you do not exceed the maximum fill mark on the gel tank. The 1 times TAE can be prepared by diluting the appropriate amount of stock solution, which is 50 times TAE, with either bottled or distilled water. To remove the glass plate from the gel mold, use the 2 gel wedges provided. Alternatively, you can use the tip of a spatula. Place the tip of the gel wedge in the space between the glass plate and the gel mold, and carefully applying a bit of pressure, lift the glass plate from the gel mold. Transfer the glass plate holding the gel into the electrophoresis tank with the gel portion facing upwards. Ensure that the surface of the gel is covered to a depth of 1 to 2 millimeters of the running buffer. Now that the gel is set and ready, next is to load the samples into the gel wells. For better visibility of the wells and to facilitate sample loading, a black mat is placed underneath the gel tank. Carefully load 4 microliters of the samples per well. The samples already contain the loading die. Remember to include your ladder as well.